Hello everyone, welcome to Chemizon Complete Chemistry. So in our today's video, we are going to understand a very important concept of electrochemistry, that is to understand the electrochemical series. So we will try to understand what is electrochemical series, and we will also try to understand how to calculate the standard electrode potential or E0 cell for a electrochemical cell. So this is the image of the electrochemical series which we will be seeing, and try to understand what does this exactly mean, and we will also see how to calculate the standard electrode potential or E0 cell for a electrochemical cell. So let us first try to understand the expression for standard electrode potential. So E0 cell, which is nothing but the standard electrode potential, which we had already discussed in our last video, that is nothing but the electrode potential that is measured at some standard conditions, that is pressure should be 1 atmosphere, temperature should be 25 degrees Celsius or 298 Kelvin, and finally the concentration of all the ions in the electrolyte should be 1 molar. So this is the expression for standard electrode potential. So we know that in an electrochemical cell there are two half cells, that is the oxidation half cell where oxidation is taking place at the anode, and there is also a reduction half cell where reduction is taking place at the cathode. So the oxidation half cell has the oxidation potential, which is nothing but E0 oxidation of anode, and the reduction half cell has the reduction potential, which is nothing but E0 reduction of cathode. So this is the basic expression for electrode potential or standard electrode potential, that is nothing but E0 cell. But according to the IUPAC, the standard reduction potential is measured for each half cell. So we have to find out an expression by which we can substitute this term of oxidation potential for anode into reduction potential of anode. So that is nothing but, so E0 oxidation of anode is nothing but minus of standard reduction potential of cathode. So the value remains the same, but just we apply the negative sign. So when we substitute this equation into the first equation, what do we get? So E0 cell is equal to, I have replaced this E0 oxidation of anode by minus E0 reduction of anode, that is nothing but the reduction potential of anode, plus this thing remains the same, that is E0 reduction of cathode, that is reduction potential of cathode. We can also write this equation as E0 cell is nothing but E0 reduction at cathode minus E0 reduction at anode. So this is a very important formula that will be useful to us in understanding the Nernst equation, which we will be studying in the next video, and also it would help us to determine some important thermodynamic concepts about the feasibility of an electrochemical cell, or whether an electrochemical cell would be spontaneous or not. It would be very helpful to know how to calculate E0 cell, that is the standard electrode potential. So to remember this, we can also write this E0 cell equation in this way, that is E0 cell is E0 reduction of right hand electrode minus E0 reduction of left hand electrode. Now why I'm calling cathode as the right hand electrode and anode as the left hand electrode, we would come to know in our coming videos, of where I would be teaching you how to write the standard representation for an electrochemical cell. So that time I will explain to you why cathode is called as right hand electrode and anode is called as left hand electrode. So this is a very important formula that we have to remember, that is nothing but E0 cell is nothing but the reduction potential of cathode minus the reduction potential of anode. Now another question is, if I give you any two half cells, how do we come to know that which half cell will undergo oxidation and which half cell will undergo reduction. So for that, we have to study the concept of electrochemical series. So this is the image that you can see is of the electrochemical series. So always remember that we had also discussed in our last video that so these potential values, that is the voltage that we can see here, are all reduction potential, that is the standard reduction potential values of all these half cells. These are the reactions of half cells as you can see here. So higher the value of standard reduction potential, more is the tendency of that half cell to undergo reduction. So these half cells at the top that you can see can very easily undergo reduction. As you can see here, fluorine, chlorine, oxygen, these are all very electronegative atoms. These are most electronegative elements, and we know that these elements have the tendency to easily grab electrons or easily undergo reduction so that they complete their octet and they become stable. So that is why the topmost half cells in this electrochemical series are the species which can easily undergo reduction, or we can also call that they are the best oxidizing agents. So fluorine, for that matter, is the best oxidizing agent in the entire periodic table, as it is the most electronegative element of the periodic table. So these are the half cells which would normally undergo reduction, since they have very high reduction potential. And we also now know the reason why they easily undergo reduction, that is to complete their octet and become stable. Now let us go at the bottom of this series, where you can see these metals which are generally from group 1 and group 2, that is lithium, magnesium. These are metals which can easily lose electrons. They are the most electropositive elements in the periodic table. So these can easily lose electrons, and hence these are the species which can easily undergo oxidation, and hence they are called as the strongest reducing agents. So if you want to select a half cell which you want to undergo reduction, you would choose from the first part, that is these top half cells can be used for the reduction reaction to take place, and you can select these lower bottom half cells for an oxidation reaction. So these are the strongest oxidizing agents, and these are the strongest reducing agents. Now let us try to understand by some example. Suppose I take any two half cells from this series. Let's say I consider this cuprous ion, that is Cu2 plus, undergoing reduction to form copper, and let us consider one more half cell, that is this zinc, Zn2 plus, gaining 2 electrons to form zinc metal. So now you can pause this video and think for a minute and tell me which half cell will undergo oxidation and which half cell will undergo reduction. So as you can see that this half cell, that is cuprous ion undergoing reduction, has a higher reduction potential, that is plus 0.34, whereas if we see the standard reduction potential for the zinc, which is minus 0.76, so this is lower. So as I told you just now, the one which is having the higher value of standard reduction potential will undergo reduction very easily, and the one which is having a lower value of standard reduction potential will undergo oxidation. So zinc would be used as an oxidation half cell, and this would be used as a reduction half cell, which is nothing but the galvanic which is nothing but the electrochemical cell which is called as Daniel cell, which we'll be seeing in our further videos, where zinc is used as the anode where oxidation takes place, and copper is used as a cathode where reduction takes place. So let us try to understand this in a much better manner by taking one more example. Suppose now I take this oxygen O2 and I take this hydrogen. So this half cell and this half cell. Again, you can take a moment and pause this video and try to understand which half cell will undergo oxidation and which half cell will undergo reduction. So we can again see that this half cell of oxygen has a higher value of standard reduction potential, that is plus 1.23 volts, and this half cell has a lower reduction potential value of 0 volt. So this half cell will undergo reduction very easily since it has a higher value of standard reduction potential, and the other one, that is of hydrogen, has a lower value of standard reduction potential, and hence it would undergo oxidation. So these are the two half cells that we will be seeing in case of fuel cell that we will be studying later, where this half cell would be used as the cathode where reduction takes place, and this of hydrogen where oxidation takes place. So in this way, by analyzing the electrochemical series, we can identify which electrode would undergo oxidation and which electrode would undergo reduction, or which half cell will undergo reduction. So now we can easily come to know that which electrode would undergo reduction and which electrode would undergo oxidation by analyzing this electrochemical series. Remember, higher the positive value of standard reduction potential, greater is its tendency to undergo reduction, and better is the oxidizing tendency, and hence they are called as stronger oxidizing agents. And higher the negative value of standard reduction potential, lower is their tendency to undergo reduction, and they are very easily undergoing oxidation, and hence they are called as the best reducing agents. So now the question is, from where do we get these values, or how do we calculate these standard reduction potential experimentally? So in our next video, we will try to understand how do we calculate these standard reduction potential values, and we will also try to understand some more applications of electrochemical series in our coming video. Thank you so much. Please do like, share and subscribe to our channel for getting latest updates and notifications. Also, please press the bell icon. Thank you so much.